So I'm going to start off by explaining its complement, which is black box monitoring. And the idea of black box monitoring is you're looking at your system as a black box. You don't know what's going on inside it. You're just trying to interact with it in principle like a user would. So examples of this, if you're sending a ping, if you're doing a basic HTTP request, or if you have a pipeline, you might, for example, put in some data and wait a while for it to appear on a dashboard. There are, however, some limitations to black box monitoring, because fundamentally, black box monitoring is like a smoke test. It tells you if things are going hilariously wrong, but it's not particularly good for subtlety. Because, well, it's only looking at systems from the outside, and because it's basically an integration test or systems test, it tends to be quite flaky, because it can either succeed or it can fail. So alerting people based on this doesn't tend to work out too well, because you have to wait for it to fail for like 10 minutes just to be safe. By contrast, white box monitoring, it's worth getting data from inside your systems, things that are going on, like that you have insights from there. So it could be something as simple as CPU usage. It could be the number of requests triggering an obscure code path. It could be, hey, how many payments are Visa versus MasterCard? Because maybe one of those is being dodgy right now. So anything you can get from the inside of your system, and then it allows you to do analysis and math on top of that. So in this context, Prometheus is a white box monitoring system. It's based on a monitoring system in Google called Borgbon, and it was started in 2012, actually here in Berlin, by some ex-Googlers working in SoundCloud. It's primarily written in Go, and we released version 1.0 there about 2 months ago. We figure, and it's very hard to tell because it's an open source project, there's probably at least 500 companies using it, such as DigitalOcean, Ericsson Weave, CoreOS, and at least 2 sponsors of this conference, I think. So then the question of, okay, we know what white box monitoring is, and it's like, well, what is monitoring for? Because in my role, I talk to lots of people about monitoring, and they have very different ideas about what monitoring is. Like some of them wonder, hey, are you the guy who knows if I access Facebook from work? Which is not really the sort of monitoring we're going after, because here what we're doing is we're monitoring machines and systems rather than humans. So I see it as there are 4 core things that you are looking at when you're monitoring. The first is knowing when things go wrong. The second is then being able to debug that. Then in a longer term, we want to kind of trend and see changes over time, do reporting. And the final 4th one is just plumbing, when you need to get data from A to B, and well, I've got a hammer that looks like a nail. So when people think monitoring, they're normally thinking alerting, because that's the main thing people are looking for, right? Because you want to know when things are broken. You want to know when your customers are hurting. And you want to be woken up at the right times so you can fix that. And then we need to question about, okay, when do we want to be waking up? Because do we want to be woken up for, hey, that machine was slightly busy for 2 seconds and it's okay now. There's no point in waking someone up in the middle of the night for that. That's just wasting the time and attention of your engineers, and they will burn out. Engineers woken up in the middle of the night are not productive engineers. So in this case, what I need to think about is if we're going to alert humans, we need to choose carefully which alerts we're going to send them and how to make them care about. Because we are humans, we are limited in cognition. So there's 2 ways you can generally approach problems: symptoms and causes. If you think about something that affects the user like high latency, there are many, probably hundreds of things that can cause that, from high CPU usage in the box, increased requests, maybe a network device is being dodgy. There's all sorts of problems that could be causing that. On the other hand, the problem here is actually high latency, which is a symptom. And if you alert on that, it's going to cover all of those causes, including the new ones you can't think of. Because trying to do these in advance doesn't work out too well. And your system is continuously changing. So let's take a classic example. For those of you who are used to Nagios, you've probably seen this one several times. Nagios class systems are relatively limited in what they can alert on, because they basically run a shell script, and if it fails, wake you up. And this is done on a per machine basis. So that's very limiting, because you can't see inside your applications, and you only have machine level stats which you hope will kind of correlate with things that you and your users actually care about. So you take something like CPU usage, because what you actually care about is end user latency. And if you're using 95% of CPU in the machine, there's a moderate, good chance that that's going to cause high end-user latency. But that's not always going to be the case. It could just be, hey, log rotation took a little longer than usual in the middle of the night when no one's using the system. That's not worth waking someone up for. Conversely, if there's a deadlock, well, your system is going to be using no CPU, and your users are going to be really annoyed. So you've got lots of spammy alerts that only catch some of the problem, lots of false positives, lots of false negatives. It's not a great situation. So you're in a situation where your monitoring system is limiting exactly and precisely what you can alert on, and you're having to put up with this. Because if you look at the wide swathe of monitoring solutions out there, because there's maybe 100 of them out there, if you look about commercial and open source, a lot of them just kind of look at the edge of the systems. Just the simple things you think about, like, hey, there's requests coming into the system, and there's stuff coming out talking to the database. And we're going to watch those. Whereas in reality, if you think about your service, right? Let's say you have a microservice architecture, which is a tree of services all talking to each other. Inside each of those services, there's also a tree composed of all your libraries, all your subsystems, like your RPC subsystem, your business logic, your middleware in there, and you should be monitoring those in the same way as you would the entire service. You want to know the query rate, you want to know the error rate, and you want to know the latency, so you can debug that down. And the idea of the Prometheus style of monitoring is that every single one of those subsystems has instrumentation where you've told it, hey, these are the things I want monitored. Prometheus grabs that all at the process level and monitors. And it goes a step beyond that. Because we don't just think about, okay, now here's this process. We think, here's this service, which is composed of however many machines. Because if you think about it, if you're offering a user service that's running across 100 machines, and one of those is being a little slow, because let's be honest, with 100 machines, one of them is going to be a little slow. Now, let's assume that that machine on its own is out of SLA, it's too slow. But the service as a whole is still meeting your customer expectations. Is that worth waking someone up in the middle of the night? No, it's not. We can wait until tomorrow or next week to solve it, because we're still providing the service we need to customers, and there's no point wasting an engineer's time, waking them up at 3 a.m. and making them unproductive, just for the sake of, well, something's slightly wrong that we should get to sometime. So you need to look at things as services and the overall latency and user impact, rather than, hey, here's one thing that's not perfect, because failure happens. And that's one of the things that when you have a service level view and the ability to work on that data, you can choose to alert on what matters to you. So if you want to know the error ratio across a data center, or across an environment, or across a customer, you can do that. Or latency, or data taken through a pipeline, or anything else you want to do. But the important thing is that you have alerts that are relevant to what the customer experience is, or the user experience, and that these require intelligent human action. Because if you're ever in a situation where you get a page, look at it and go, meh, that should not have been a page, right? You should be aiming for any given page to be like 90% useful at least. Because we're here to automate, we're here to be engineers, not to be operations monkeys. The second part of monitoring then is debugging, because yes, you just got your page, which requires intelligent human action. The problem is intelligent human action implies complicated, because you have this system that you've built up over however many years, and it's got lots of bits and pieces. So you need to be able to go from something symptom-based at a high level. It's like things are slow, because that's basically what a high latency page is telling you. It's like, yes, things are slow. Good luck. So you need to think, how are you going to work down from that to figuring out the problem? Now, there's an anti-pattern called the wall of graphs, where you have a dashboard which has a wall of graphs. The worst one I've personally seen was 600 graphs on a page. There is evidence out there that someone managed to hit 1,200 of these on a single page, which humans can't deal with that. It's just too much data. Also, it takes 5 to 10 minutes to load, just because it's 600 graphs. So you need to think about it more intelligently. If we go back to our tree of services and our tree of subsystems, what if we start off, look at the top level, where we're getting this high latency, and we see, okay, is this service overloaded? Which of its backends has gotten slow? Oh, it's that one. Right, look at that service now. Is it overloaded? Which of its backends has gotten slow? Oh, it's that one. Okay, we'll look at this service. Is this overloaded? Ah, yes, this one's overloaded. It's running out of CPU. Great. Now let's look at the subsystems and drill in there and see what's going on. And just taking that sort of intelligent approach to walk the tree of your service. So obviously Prometheus has lots of dashboarding options. Yay. You can use Grafana if you're used to it. You can do custom stuff. It's just a HTTP JSON API. But the more important thing is how you design your dashboards and think about how you're going to use them in an outage rather than how pretty or not pretty they look. And the other thing is that, well, you need data from every level of your stack. Because if you can't just be monitoring your application, you also need your MySQL servers, you need your front ends, you need your VIPs, you need stats from all of these. Otherwise, you've got this kind of blob in the middle where it's a bit too black boxy. So when you're looking at a monitoring system, choosing any monitoring system, you need to look at the integrations. So if you have somehow gotten that 8-bit CPU from Minecraft and want to monitor what the FPS is, you can do that with Prometheus. And recently as well, Factorio, if you've somehow managed to integrate Factorio into your production system, you can monitor that with Prometheus. Good news. Also, more practical things like Cassandra, MySQL, Node.js, SNMP, which we all love. And as well as that, you know, let's be honest, not everyone is going to choose one monitoring system. Some of your tools have chosen, you know, we're just going to do StatsD, or we're just going to do Graphite, or InfluxDB, or Prometheus, or whatever. So one of the things we have with Prometheus is the ability to plumb these all together. So it is possible with Prometheus to say, hey, this only inputs data to InfluxDB. So you run the Prometheus InfluxDB exporter, and then chuck that out to Graphite without ever talking to Prometheus. So this nice open ecosystem, because it's an open source project, we can just plumb data around so everyone has to stop re-implementing all these things. Because it's silly that every single monitoring system has to write a MySQL integration, and a CloudWatch integration, and a Postgres integration. Instead, let's just do this once, reuse it, and maybe you can never use Prometheus, but at least you can take advantage of the fact that we've figured out how to monitor all these things. And the other thing is, though, that all the stuff I'm talking about here, it's great. It's awesome. But it's just one part of the story. You see lots of people talking about, hey, I want one integrated monitoring solution that does everything. Like, it'll automatically tell me the problems, it'll do anomaly detection, it'll make me a coffee, it'll give me a unicorn on demand, you know? Unicorn on demand, next big thing. But in reality, that's not the way things work. There are multiple different types of problems, and each need their own tool. And it's important to recognize that, because if you try to build one thing that does everything, you end up with something that really does nothing. So Prometheus, we know what it does. It does time series. It does metrics. It does it well. But you need other things as well. You need some logging system like the Elk Stack or Splunk or whatever else you've chosen to use for that. You're going to need profiling tools. Like anything Brendan Gregg talks about, you need all of those as well. You're also going to need, well, your source code. Because at the end of the day, if you're having a problem, you might need to improve there. And just then you need to walk between these. So when you're debugging, you can jump between these. So maybe you start off with a problem that's high latency. And you drill down using your graphs in your metric system to say, oh, look, it's due to the billing subsystem. Okay, we've gone down to the service of the billing system. Then maybe you look at logs and see, okay, what are the slow requests coming in that are hitting the billing system? It's like, oh, right, it's this customer doing this thing. Right, maybe I'll look at the source code and see what that does. And maybe I'll profile it to figure out why the hell it's being slow and discover, oh, wait, there's the n-squared loop. And just bouncing between these different sources of information to get a whole view of what's going on so you can fix it. The third thing about monitoring then is trending and reporting. If you're talking about alerting, you're talking about debugging, you're talking on the scales of minutes to maybe a day or two. Longer term decisions, you're talking months to years. You're looking at things like, hey, where's my cache hit rate going? Where is my query rate going? How much throughput, how many queries I need to serve? The salespeople are telling us we're going to get so and so many customers. How does that impact all of my decisions? Which features are still being used? Which ones can we turn off because no one's using them? So these are the sort of analysis you want to think about. And once you've got that data, the advantage of a monitoring system like Prometheus, and something you should be looking for any monitoring system, is what sort of analysis can you do out of the box? And Prometheus actually comes with an extremely powerful query language, because you can basically do anything you want with it. Add, subtract, aggregate, do joins, and you can answer questions like 95th percentile latency per data center. Or how full will the disks be in 4 days? Another wonderful alert. Disk is 95% full. Everyone's gotten that alert at some point, right? The problem is there are basically two approaches to disk-space alerts. You either have the there is 5 gigabytes left, or there is 5% left approaches. And each of them works well on one of large disks or small disks, but not the other. The advantage instead, if you go for how full is it going to be in 4 days or an hour, is, well, you're not going to get paid for, yep, we just went from 94.9% to 95%, and we've got 3 years before it fills, which is, we've seen that one too, right? To like, wait, no, this is going to fill up, we think, in 3 days. Maybe we need to page, maybe we need to get a ticket or whatnot. A much more powerful way of doing alerting because it's just respecting the people who are on call more. And you can also do things like, hey, which services are using my most CPU so we can have a word or optimize them. So here's an example of an actual Prometheus query working off cAdvisor to get some Docker stats. So we're saying, hey, all my containers across the entire fleet, all the Docker ones of those, how much CPU are you using per second over the last 5 minutes? Then we're going to add that up by Docker image, not by machine, not by service, not by environment, not by customer, not by anything else, by Docker image, because that's something we can do, and give me the top 5. So this query will then tell me where I'm spending CPU in terms of Docker images, so maybe I can go to those and go like -03 rather than -02 and save myself some power. And you can imagine how this can apply to many other things where you can slice and dice in any dimension you want, not just the predefined ones that you picked 3 years ago because they seemed the right ones at the time. And this brings us to one interesting aspect of Prometheus, and other monitoring systems as well are starting to move in this direction. If we use the graphite, everything is a dotted string. You must choose a hierarchy in advance that you are going to be querying on using globs. This works well until you need to do a query that doesn't follow that, or someone puts a dot in something and doesn't escape it. Escaping people, it is a thing. Also sanitizing. Choose one, I don't care. Just don't put dots in your values like this. Prometheus takes a different approach. Some people call it dimensions, some call it tags, but not all tags are labels. Everything's just an unsorted set of key value pairs. So I can just say like metric event equals BOP, city equals Berlin. And then I can slice and dice on that any way I want, just like the previous example with the Docker images. These could come from instrumentation, like from your code, that knows, hey, this is Visa versus MasterCard, this is a get or a post. Or it could come from how you view your system. It's like, no, that's the production environment, that's the dev environment. Oh, and that's the European cluster, that's the Asian cluster. And these combine together so you can slice along those any way you like. So here's an actual example of some labels in Prometheus. So this is from the node exporter, which is our machine agent. And the metric here is called node network receive bytes, which is, well, the amount of bytes the network card has received. And this is a Docker machine, so we can just see for each of them, we've got the instance label, the machine, and then each of those devices. So I could aggregate up and get total network traffic going across all devices on that machine. Or I can say, hey, ETH0 across all my machines, how many is that? And those sort of analysis. I can even say, hey, how many network cards does each machine have? And then aggregate that and do math on that. You also want to get data from your code, because the real win from this stuff is like, yes, we can monitor our infrastructure. We can monitor our Minecraft. But wouldn't it be nice to be able to get actual business logic? Because that's where the real wins of this stuff comes from. And this is actually a complete example of how to do Python instrumentation. It's going to output zeros, but it's a complete example. Because what this will do is it installs the Python client, does some imports, creates a metric called request duration seconds, which has a help string, because help strings are handy, and it just uses a decorator to time this function. So it's going to track how many times that function is called, and it's going to track how long it takes to run. And then we just pass it out over HTTP when asked for. Nice and simple. And this is not, as I previously mentioned, limited to talking to Prometheus. You add 2 lines of code. Instead of saying start HTTP server 8000, you go, I think it's graphite push or something. You give it the name of a graphite server. You give it how often, and it'll push that as well. So this is not tied to Prometheus. You can just take advantage of this and push this data out to whatever monitoring system you have, because we're an open ecosystem. And if you want the labels, it's another 20 characters. Nice and simple. And this also works with graphite. We just flatten it down. But here, if we want to break out requests by get versus put versus delete versus head, it's that simple. Thing as well, the fourth thing is plumbing. Because sometimes you just need to get data from A to B, and my monitoring system looks convenient for doing that. If you consider something like a hard disk failure, at the end of the day, you need a human to go in and fix and replace that hard drive because the robots aren't good enough yet. So you need to generate that alert that's plumbed through somehow. And if you're looking at a monitoring system, you need to see what integrations are there, how easy is it to hook in, will I be able to get my data back out again? So in Prometheus, we know we can't solve everything. Right? You get lots of feature requests in where it's like, wait a minute, how many different providers are there to send SMSs? We can't support all of those because there's going to be like several per country minimum. So that's like 600, 700 of those. That's not going to work. Instead, we have an integration where we say, right, look, we'll send JSON to you, do what you like with it. And we've got integrations throughout the stack to do whatever you like. So if you want a shell script to run when an alert fires, off you go. If you want to run a shell script to get data into Prometheus, off you go. If you want to run a shell script to tell you where all the servers are so Prometheus can find them, off you go. These are all there for integrations so you can do what you like. Now we get to the fun part, the live demo. This is definitely going to be fun. Going to show you how easy it is to get Prometheus up and running. And this is literally from scratch because this laptop's not pre-prepared. Now we just need to find out where that downloaded to. There we go. Oh, for... Cool. So we can run a Prometheus server. Where's your /? Okay. So here it is. It's that easy to get a Prometheus server up and running. Now here it's using the sample configuration, which isn't going to work out too well. You have Vim installed. At least Vim is installed. Right. So I'm just going to trim this down. Okay, so it's monitoring itself. And we're also going to make it monitor this machine. Where's the Y? And by this machine, of course, I mean the live demo that actually runs Linux, because we've got more stats that way. No, next, there we go. Good. Yes, that's this machine, honest. Sorry, that's port 9100. Cool. Colon Q, WQ. There we are. Right, so there's our Prometheus server nice and running. And if we go back then to Safari, so let me just make this, where's the plus symbol? There we go. Nice and bigger. There we are. So, colon 9090. There's a Prometheus server. And we'll see here it's actually monitoring the local host, which is actually a machine off there. And you can actually see the metrics format. Open a new tab. Yeah, so here's the actual stats that Prometheus server is reading in. So this is a whole pile of command, Prometheus stats. So we can actually see some labels here. So here's some internal Go stats. And then we start, here's the disk read time. So here's your disk latency for reading. Yeah. And then your file system stats, your memory stats. And then we'll get on to the 300 or so network stats. Yeah, it turns out there's a lot of stuff in /proc, and we dump all of it. So we can actually, same with Prometheus itself is also exposing metrics. So we can go graph, and I don't know, node, context switches. There we are, a nice graph that's going up and to the right, which is what you always want. Because that's the total number of context switches. As something a little more useful, we can actually see the rate of that per second then. Here's our rate. Where the hell are square brackets? Yeah.
It's like L 5 and 6.
All right, okay, thank you. Yes, there we go. And then we can see a graph of that. In fact, there's even some inbuilt consoles. Oh, good. Colon 9090 // Please work. Here we go. And this is completely dynamic that has picked up this node because you saw I typed that in only one place. If there were more nodes, they'd automatically pick up here. And we can get some basic graphs out of this for the total of 2 minutes this has been running. So all the stats you could want there with memory, disk, file system, all being pulled up. Our CPU stats are here as well. Yeah. I have a PR out to fix this, don't worry. And then here's all the disk stats as well. And even the Prometheus server itself, we can see that this one running right now on this laptop is viewer stats, doing 210 samples per second it's pulling in, which is pretty small. And you see as well all the requests coming in. So this is actually seeing inside your Prometheus server and what it's currently doing, which isn't much because it's just monitoring itself and a random node exporter. But if we look then at demo.reception, great. Oh, no. So there's a public demo as well running. So we can see, for example, Grafana dashboard, which is all integrated. So we can see here's the host stats, and that looks far prettier. Or we could also look at the Prometheus itself, and the same health information is there. So it's only this other Prometheus has got 3,500 time series, which isn't much. But it is using half a CPU, which is rather a lot, but there's a reason for that. And the reason it's using so much CPU, and I'm very proud of this, is this. Yeah. It turns out that Prometheus is a really, really powerful query language. So powerful that it's Turing complete and can implement Conway's life. And yet, that machine permanently spends half a core doing that. I've still to see a glider. Those come close. So then, this one here. And just do this. So we'll just... I've done a most interesting live demo, and you can tell it was live, but that is how easy it is to run things. It's even easier if you can use the keyboard. So to summarize then, the things that you should be looking at from your monitoring system, whichever one you choose to use, is the ability to alert on symptoms, not causes. So you can get the pages that actually matter. You then want to be able to debug those in a way that doesn't involve looking at a wall of graphs or sacrificing a chicken and hoping the entrails will point you to the right subsystem. You want as well the more long-term trending to allow you to optimize your systems and make good business and engineering decisions. And you need easy integration points because, let's be honest, no system is going to do what you want perfectly, so you need to be able to integrate. At that point, we'll ask for questions.